Okay, so we'll start off with the questions that we came up with for answering after we'd been in the lift. So we decided that for accelerating upwards, when the lift first begins to move up, and when it's decelerating downwards, when it's slowing down the way, that the scale reading increases for both of those situations. For the situations of accelerating downwards and decelerating upwards, we decided that the scale reading decreased, so it went down. For a constant speed, it stays the same, so whatever it is on the ground, it's the same when you're at a constant speed in the lift. The last part there was explaining why the scale reading changes, and that was the hard part. It involves Newton's third law, so we went on to explain that by using a free body diagram like this. So in a lift, when you're on this set of scales, you've always got weight acting downwards. Your weight is shown on those scales. They were Newton scales, but for every action force, as Newton's third law says, there's an equal and opposite reaction force. So there's a reaction force which we called F up. So that must be equal to W, otherwise, you know, it would either fall through the lift floor or it would begin to rise, which it doesn't do. It stays on the floor. So F up is the one that's going to change. This is the one that we're going to change as we go through. If that changes, then W has to change as well. So that's why we end up with W increasing, our weight increasing, or our weight decreasing. But that's something that we refer to occasionally as apparent weight, which is slightly different from actual weight, because your weight itself doesn't change. Your mass has stayed the same, gravity has stayed the same, so W equals mg will give you the same value, but your apparent weight, the weight that you appear to have in the lift, has changed as a result. So if we start off with stationary and constant speed, then this reaction force F up is equal to W, it's equal to the weight. So therefore there's no change to the weight because there's no change to the reaction force. Forces are balanced, so we haven't got any change there. It's only when we're accelerating or decelerating that we end up with an unbalanced force going in a particular direction that the weight will change. So we started off with accelerating up and decelerating down. We've still got weight acting down the way, we've still got F up, the reaction force, but we're now accelerating upwards. Our unbalanced force is in the upwards direction, and that holds for accelerating up or decelerating down. So therefore, this is in the same direction as this, so we add these to each other. They are bigger than your normal weight would be, so your apparent weight increases so that the action and reaction pair are matched up. So we say for your apparent weight, or F up as we've been calling it, it would be W plus the unbalanced force. The unbalanced force gets added on to your weight, so your weight increases as you accelerate up or decelerate down. The fifth and sixth types of motion that we discussed were decelerating up and decelerating down. The acceleration is in the downwards direction, so therefore the unbalanced force is in the downwards direction for both of these. Unbalanced force is going in the opposite direction to F up, so it gets taken off of it. So therefore the weight has to decrease in order to make sure that it's the same as this reaction force down here, because remember that's the one that changes all the time. So because of Newton's third law, every action force has an equal and opposite reaction force, then the weight decreases so that it matches up with this value for F up. The last one that we looked at was if the rope snaps. The rope snaps and leaves you and the scales and everything in the lift going downwards at the same rate, so the forces are balanced and your apparent weight is 0. So there's a wee rhyme that you can use that we introduced there to remember it. AUDD plus, DUAD minus. So accelerating up, decelerating down, your apparent weight increases. Decelerating up, accelerating down, your apparent weight decreases.